Welcome to ICDD's InSession webinars. Justin Blanton, ICDD's Manager of Engineering and Design, will present new features in the 2024 powder diffraction file. Please remember to visit ICDD.com for information on future free webinars, educational events, product information, and to purchase ICDD's databases and software.
Okay, so thank you for joining us for the new features in the 2024 powder diffraction file webinar. So again, my name is Justin Blanton, and I'm the Engineering and Design Manager here at ICDD. Okay, so the first thing I want to talk about is the new PDF5 Plus 2024 database. So the PDF4 Plus and PDF4 Organics databases have now been combined into a single database. So if you're a user of a PDF4 Plus database or a user of a PDF4 Organics database, you're now going to transition into the new PDF5 Plus database. So you now will have access to over 1 million PDF entries, and these contain both the inorganic set and the organic set of data. You will be able to use both sets of data simultaneously or individually. So I'm going to show you a database demonstration on how to do dataset switching in the new PDF5 Plus 2024 database. So now I'm going to switch over to the database here. So here's the search form, which many of you might be familiar with. Now, if you look at the top toolbar on the right-hand side, there's now a new three-way dataset selector. So by default, I have all data selected here. So when this button is selected, whenever you do a data mining search or a phase ID search, it's going to search the entire PDF5 Plus database, which includes over 1 million entries. Now, there are two other buttons to the right-hand side. The one on the top says inorganic emphasized. So when you have that button selected, it's going to search essentially what would be the PDF4 Plus set of data. Now, when we say inorganic emphasized, what we mean is that it's going to contain mostly inorganics. So if you're working with inorganics, this is the button you're going to want to have selected. However, it's going to include some common organics that you might find in your analysis. Now, the button underneath that says organic emphasized, when you have that selected, that's going to be like searching the PDF4 Organics database of prior releases. So this is going to contain all the organic data in the database, but it's also going to include some common inorganics, again, that you would find in your analysis. A good example is if you're working with pharmaceutical materials and you have organic emphasized, it's going to include some of those inorganic excipient patterns. So how does this work? Well, if I have all data selected here on the toolbar, and let's say I do a subfile search, and I want to look at all the micro and mesoporous patterns in the database. So I have micro and mesoporous here selected in the subfile list, and then I'll click the search button at the bottom left. So now it is searching the entire PDF5 Plus database of over 1 million entries, and it has given me 19,000 entries. So there are 19,000 entries in that subfile in the entire PDF5 Plus database. Now, if we're just working with inorganic materials, and I click the inorganic emphasized button here, and then I do the search again, we now only have 7,400 entries. So since we're just honing in the organic emphasized data set, we're only looking at 7,000 entries as opposed to the 19,000 that are in the entire database. Now, conversely, if I have organic emphasized selected here, and then I redo the search, now we're looking at 13,000 entries. So now we're looking at the organic set. So it's very easy to switch between all data, which is the 1 million entries, or organic emphasized or inorganic emphasized, depending on the type of analysis that you're doing. And again, this three-way data set selector applies to all my searches and all of my phase ID searches. All right, so let's move on to a data mining search example. So if you're not familiar with data mining in the PDF database, I'm going to give you a step-by-step demonstration on how you can take some targeted searches and get essentially a narrow list of search results that you can use for your analysis. So in my example, we're working with clinical patterns. And to search for these type of patterns, first, I'm going to do a subfile search. Because I know the material that I'm working with is a clay mineral, I want to do a clay search. So let me add my laser pointer so you can see here, here's the subfile searches. And then when I select clay here, that's going to include all the clay patterns in the PDF5 Plus database. Now I'm going to add an additional search. So let's say my XRF analysis indicates that the material I'm working with has the following elements. It has aluminum, chromium, hydrogen, magnesium, oxygen, and silicon. So I'm going to add those 6 elements by simply clicking on the buttons on the periodic table. So you can see that those 6 buttons or those 6 elements are now highlighted in white, and those are selected in my periodic table search. Now I'm going to add a third search. So I know my material was analyzed under ambient or room temperature conditions. So because of this, I'm going to click the ambient button here under the environment search, because I just want to restrict my searches to only entries that were taken under ambient conditions. I don't want to look at non-ambient patterns, and this would include high temperature patterns or high pressure patterns or low temperature or low pressure patterns. So I don't want to see those. Now I'm going to add another search, and I need atomic coordinates for my quantitative analysis. So when you're doing a data mining search, sometimes you have to ask yourself, well, when I get my data, what am I going to use it for down the road? And since I'm going to be doing a Rietveld refinement, which is a type of quantitative analysis, I need the atomic coordinate data to do that quantitative analysis. So I'm going to have atomic coordinates checked here, and this is going to only retrieve patterns that have the full atomic coordinate information. Now, lastly, I just want the highest quality data available. So in this case, I'm going to use the quality mark search. So every PDF entry in the database is assigned a quality mark, and that designates the type of quality of that particular pattern. Now I have star patterns here. So I have the check mark next to star selected, and that means only the star patterns or the highest quality and highest accurate data are going to be included in my search results. So once I've added all those 5 different searches, and you can see that I have the subfile search, I have the environment search for ambient patterns, I have the elemental search, and I have the atomic coordinates and quality mark searches selected. Once I've added those, then I'm going to click the search button at the bottom to get my data mining search results. Now, let me show you exactly what's happening when you do a type of data mining search like this. So we're looking at the PDF5 Plus 2024 database. And this database has 1 million entries, 61,889 entries. Once we add that clay subfile, so since we knew we were working with clays, I had selected the clay subfile under the mineral-related subfile search. Now we're down to just 329 entries. So this really shows you the power of using subfiles. We can essentially take 1 million entries and narrow it down to just 329. Now, once we add our periodic table search, so we had our 6 elements that were taken from the XRF analysis, now we're down to just 16 entries. So using these 2 highly targeted searches, we're now down to a fairly manageable subset of entries. And we could probably just stop here and start combing through these 16 entries to look at the data and analyze it. But I'm going to go further and show you what happens when you use those additional searches. So when we apply the ambient search, well, we're down to 15 entries. That shows us that one of those 16 entries was a non-ambient pattern. When I look at the patterns that only have atomic coordinates, now we're down to 12 entries. And then if I look at just the highest quality patterns within that set, I'm down to just 4 entries. So using these 5 different searches, I've been able to take 1 million entries down to just 4 entries. And when you do this search, you get the clinichlor patterns, and these are clinichlor chromium bearing patterns in the database. You can look at the search results, you can display and customize your display fields. You can look at the search description that was performed. And at the top, you'll see that there's a search menu and toolbar. And this gives you access to the PDF entries and simulations. And it also allows you to create data mining graphs and do whole pattern matching. So that was an example of how you can do data mining in the new PDF5 Plus and how you can take 1 million entries down to just 4 entries using some nice targeted searches. So in developing the new PDF5 Plus database, because we had essentially doubled the number of entries as compared to the PDF4 Plus and PDF4 Organics databases, we ran into some issues where we found some searches were taking a lot longer to complete. And this is just because of the sheer number of entries now. Since we're working with 1 million entries, we found that some of the elemental searches were just a bit too slow for our liking. So we looked into some of the algorithms, and there are essentially 2 algorithms where we were able to essentially optimize the searches. So the first algorithm is the only Boolean operator. So when you do an only periodic table search, that is going to include all the PDF entries that only contain those elements that you're looking for and no other elements. So in my first example here in this chart, I have only boron, carbon, and nitrogen. So that is going to return the entries in the database that only have those 3 elements, but they cannot contain any other elements. So we found in last year's PDF4 Plus database that took 2 seconds to essentially complete that search. So that's not an exorbitant amount of time, but we felt that we could increase the performance even better. So using some new algorithms, we've been able to take that search down to just 0.5 seconds. So now in the 2024 database, not only are we searching a database that's twice the size of last year's database, but we've been able to cut down the search time from 2.6 seconds down to just 0.5 seconds. There's another periodic table Boolean operator that's heavily used by many of our customers, and that's the just operator. So when you use the just operator, that essentially is searching for PDF entries that contain at least 1 element in my list of elements, but it cannot contain any other elements outside of this list. So in this second example, where I'm doing a just search for hydrogen, carbon, nitrogen, phosphorus, and oxygen, that search in last year's database, which would take 45.5 seconds, now only takes 7.3 seconds. And this was due to all the different permutations that we had to search on in this list. So you would have to search on essentially PDF entries that had only hydrogen, also PDF entries that had only carbon, and then all the permutations for the rest of elements. If you look at the third example for this just search, we're now looking at, let's see, we have 8 elements here. Now, the way the algorithm worked last year is that the more elements you search for, the longer the search. So that took 2 minutes and 38 seconds. But the way we've been able to optimize, the reverse is now true. So the more elements that you include in your just search, the faster it actually becomes. So now this search is essentially instantaneous and it only takes 1 second. So you'll find in the new PDF5 Plus database, as with all the other 2024 databases that are being released this month, the only and just element searches have been greatly improved. Now, another new feature that we've added to the PDF5 Plus database are 2D structured templates. So if you're a user who has used the PDF4 Organics database in the past, you might have known that there is a 2D structure search in the Organics database. And this is because we have all those organic patterns and we allow the user to search on these different 2D structures. Now that we've combined the Organics database with the PDF4 Plus, we have essentially put the 2D structure search now in the PDF5 Plus database. And we found that some users would search for 2D structures and they would draw these 2D structures out. But sometimes it can be tedious to draw essentially the starting structures that you see in this list here. And if you're searching on many structures, or you're doing multiple searches in a row, it can be tedious to have to draw each of these 2D structures that you're going to search for. So that's why we've created 2D structure search templates. And this allows the user to use a template as a starting structure or as a complete structure. So there are 200 templates available, and you can search by the template name. So you don't have to comb through the entire list. You can just do a search for the template name that you're looking for, and you can find that 2D structured template. So I'm going to do a database demonstration, and I'm going to show you how you can select a 2D structured template for searching. All right, so I'm going to go back to the database, and you'll see when you're using the new PDF5 Plus database, there's a 2D structure tab here on the left-hand side. So this is a new tab if you have not been using the PDF4 Organics database. And this gives you a drawing panel, which you can draw out a 2D structure if I want to. So you could add a benzene ring here, you could add multiple bonds, etc. You could also type in a smile string. So a smile string is a textual representation of a 2D structure. But I'm going to show you the templates feature. So to get to the new templates feature, you're going to click this button here that says templates. And now it has brought up the list of 200 2D structure templates that I can choose from. So you can scroll down this list and see all the 2D structure templates. If you want to add any template, you simply just click on the template itself. So if I want to add this template, I can simply click on that. And that's going to add that template to my drawing panel. And I could search on this substructure here, or I could further add bonds and molecules to this substructure. So I'm going to go back to my 2D templates and show you how I can search through this. So let's say I want to search for benz. So I type in B-E-N-Z, and here are all the 2D structure templates that have the word benz in them. So you have benzopyrene, benzoyl, benzyl, and pentafluorobenzyl. So I'm going to click on benzopyrene, and that has added that to my 2D structure panel. Now I'm going to search for this as a complete structure. So I'm going to click the search button. It's going to search the PDF5 Plus database. And I'm going to go back, make sure I have all data selected, do the search again, and now you can see here are the 2 benzopyrene structures in the database. And I was able to easily access these just by selecting that benzopyrene 2D structure template from my templates list. Now that's how you can search on a complete structure. Many times you might want to search on a substructure. So it's very easy to do that. So I'm going to reset my search. I'm going to go back to my template list. Now I'm going to click this X to clear my search. And I'm going to type alumina. So as I type alumina, and I type ALUM, so I have alum, you can see that there's 3 templates that actually have the word alum in it. So you have alumina, aluminum hydrogen phosphate, and aluminum phosphate. So let's say I select alumina. So I just want to search for this substructure. So I click this template here. It's added alumina to my drawing panel. Then I'm going to go to the 2D structure dropdown and select substructure. Then I'm going to do the search. And now it's searching the database and it's showing me all the 2D structures that have alumina as a substructure. And I can scroll down this list and view them. And that's how you can essentially access those PDF entries. So that's how you use the new 2D templates feature. All right, so on the PDF cards, we've actually added 2 new formulas. The first is the ideal formula. So this describes the general chemistry of the compound, especially in cases of minerals and solid solutions. Minor substituents or variations may be ignored in this representation. And the second formula that you'll find on the PDF card is the analytical formula. So this is actually based on experimental elemental analysis, such as an XRF analysis or microprobe analysis. And this formula is descriptive and represents a composition derived based on experimental conditions. So you can see the PDF card on the left. You'll see these 2 new formula fields underneath the standard chemical, empirical, and refined formulas. Another new feature you'll see on the PDF cards is we've added new arrow buttons that allow you to quickly traverse through the search results table. Now let me show you a database demonstration of how you can cycle through these search results using the PDF card window. Okay, so if we go back to the database, and we look at the search results here that I have on the top left here. So I'm just going to expand these a little bit so you can get a better view. And I'm going to open up this first PDF card that came from my Illumina 2D structure template search. So if I double click that table row, I get the PDF entry. And let me go back and reset my search. And then just make sure that that PDF entry is set correctly. And you'll see that when I open up the PDF card, which is giving me a little issue here. So I'm going to go back to that. Okay, so let me show you some of the new graphing features. So we have automatic vertical zooming. This allows you to essentially create a zoom window. And with the zoom window, it's actually going to start at the top of the mouse position and then go all the way down to the bottom. We've also added a gradient fill option, and this is going to show you a gradient fill underneath the area of the diffraction patterns. You can now view raw data or PD3 patterns in your search results, and the diffraction pattern preview is now going to be shown when dragging and dropping. So let me go back to the database and see if we can figure out what is going on here. So if I do a search, I get my search results. And let me go back. I'm going to actually reset my preferences. Okay, so here I'm at the diffraction pattern. And as I'd mentioned, there's now automatic vertical zooming. So to perform automatic vertical zooming, what you do is you click anywhere on the graph, and as I create the zoom window, you'll see that the height of the zoom window spans the mouse cursor all the way down to the bottom of the graph. So this gives you a nice convenient way to zoom into a diffraction pattern. So I can easily zoom into any area of the diffraction pattern without having to drag the mouse all the way down to the bottom of the graph. So let me show you that again. So let's say I want to zoom in this right-hand side of the diffraction pattern. I'm simply going to click with my mouse, drag to the right, and you'll see that the zoom window is automatically expanding and creating a zoom window from the top of the mouse down to the bottom of the zoom window. So this will allow me to easily zoom into this area of the graph here. Now, if you want to essentially create a free zoom, and this is the way that you're probably more used to zooming, all you have to do is hold down the control key and then click with your mouse to create a zoom window, and you'll see that the zoom window is now going to exactly where I put my mouse cursor here. But once I release the control key, now it's doing a fixed zoom. So it's essentially zooming and creating a window from the top of the cursor down to the bottom of the graph. So this is also the way that you would zoom in Jade. So if you use Jade, you'll probably be very familiar of this way of zooming. Now, I also mentioned that we've added new gradient fills to the diffraction patterns. So there's two ways you can access the gradient fill. You can right-click any diffraction pattern. You can select Fill Style and select Gradient. And that's going to show me the gradient fill here. Another way you can access the gradient fill is you can go to the Preferences. Under Diffraction Pattern, under Fill Style, you can select Gradient here. So when you click OK, that's actually going to essentially create a gradient fill for every diffraction pattern. And this gradient fill gives you a nice way of popping the color underneath the area of diffraction pattern. And it gives you a nice way to just kind of show you how the area is. And particularly when you have multiple diffraction patterns when you're doing analysis, it's a much nicer way of actually viewing the diffraction pattern. Now, I'd mentioned PDF3 patterns are now being displayed when you do a raw data search. So let me show you an example of how that works. So we have a raw diffraction data search here. And when I click this button that says raw diffraction data, and I do a search, this is going to search the entire database. And it's going to show me all the raw data patterns directly into my search results. So you can see that there's a column now on the right-hand side that shows you that raw data. Now, in this case, I'm only interested in the polymers in the database. So I'm going to click the polymer subfile. I'm going to make sure my raw data diffraction is checked there. I'm going to do the search. And now it's going to show me all the raw patterns for the polymers in the database. So let me expand the window, and you can resize this display field. And now you get a dynamic preview of all these raw data patterns, and these are all the polymers in the database. And as you scroll down, it's going to show you those polymers. And these raw data patterns are really nice because they exhibit atypical features. So some of these are amorphous, some of these are semicrystalline, but these are essentially showing you diffraction features that you normally would not be able to simulate using a traditional simulation algorithm for an X-ray diffraction pattern. So it's really nice to be able to view these in real time in your search results. Okay, so let me go back and show you one more feature. The diffraction pattern preview is now shown when dragging and dropping. So you can drag and drop any of these diffraction patterns into a new window by simply dragging it out of the search results and into a new window here. And what you'll notice is as you drag the search result and the PD3 pattern, you actually get a dynamic preview of the actual diffraction pattern that you're dragging here. So it's very nice and a very nice, easy way to essentially combine these patterns by dragging and dropping them into a new window. All right, so look at some of the new features with 2D structures. So you can now export 2D structure animations to an animated GIF file. So there are actually 3 user settings. So you can set the spin direction. So if you look at the 3D structure on the left-hand side, this is actually an animated GIF that was exported from the PDF5 Plus database. And I set the spin direction to spin to the right. And this actually will create a perfect loop. So when you create an animated GIF with a perfect loop, it's essentially going to spin endlessly. So it gives you this nice endless spinning animation right here. You can also set the frame speed. So this is the frame rate of the spin. So you can set it to a slow, a medium, or a high speed. And you can also set whether or not you want a transparent background or if you want a solid background. So in this example on the left, I actually set it to a transparent background because I wanted the background of the PowerPoint presentation to show through. We also have SIeve simulation patterns in the database. So SIeve patterns are selected area electron diffraction simulations. And we've worked with the company Gatan and their program, Digimicrograph, to add support for importing Gatan star.dm3 files. So for many releases, you've been able to actually import image files into the SIeve simulations. And when you import an image file, you can essentially do a visual analysis of the image compared against the simulated pattern, as you can see here. However, now we've added support for DM3 files. So not only can you import image files, but you can now import DM3 files that were exported in the Gatan software. We've also added another fill style option for the spots. So the spots for this SIeve simulation can be displayed as a gradient spot or as a solid spot. So if you look at the screenshot on the left, this is an imported Gatan image overlaid on a SIeve simulation of silicon. All right, so now I've showed you some of the data mining features, some of the simulation features that we've implemented in the 2024 release. Now I'm going to show you some of the Phase ID features. So if you're not familiar with the built-in Phase ID software, it is now included free in all 2024 PDF databases. So in past years, SIeve, which is the Phase ID software for PDF2, and SIeve Plus, which was the Phase ID software for PDF4, those are now free in all 2024 databases. So if you've not used SIeve or SIeve Plus before, I highly recommend that you check it out. It's a great complement to using it with other Phase ID programs such as Jade, or if you have other OEM software, it's also a great complement for those as well. So for the 2024 release, we've added support for 2 new file formats. These are actually based on user requests. So if you're using SIeve and SIeve Plus and you find that there's a file format that you have that you cannot import into SIeve Plus and you're not able to import it using a custom importer, please contact us and we'll look into adding support for the format that you're trying to use. So we now added support for the Rigaku ASC files, and that's actually an older format that's not used too much, but we did run into a customer who wanted to import a file using that format. And we also added support for importing the Rigaku.rasx format, and that's one of their newer formats. Another new feature is the ability to hide irrelevant matches. So this was a customer request. They were doing an analysis and they saw essentially some search results that they knew were not in their material. So they just wanted to hide them for the duration of their session. So now you can hide irrelevant matches very easily, so they're not cluttering your search results. But it's also very easy to unhide those if you do want to view those matches again. We did add support for the new NIST XSRM 660C as an internal standard. So several years ago, we did add support for setting an internal standard in SIeve and SIeve Plus when you're doing your phase ID. And we always recommend that if you are using an internal standard in your analysis, you should set that internal standard in the software. And this essentially would allow the software to use that internal standard to calibrate the peak list that you get when you import your experimental data. And it essentially just makes the analysis much more accurate. And we've also added a new single peak search to SIeve. So this is useful for minor and trace phase analysis. As a user, you'll be able to select the peak that you want to search for using the mouse. You can designate whether that peak is a strong or a long line, and you can also set the user-defined error window. All right, so I'm going to do a database demonstration, and I'm going to import a Chinese white pigment file. Now, this contains 3 common phases that you would expect in a paint pigment: calcite, anatase, and gypsum. But you'll see what happens with the gypsum phase is that because it's a very minor phase, it doesn't pop out at us in our search results. But I'm going to show you how you can use a single peak search to target that phase and essentially bring it out to the top of the search results. All right, so I'm going to go back to the PDF4 Plus database. I'm going to clear my search. And let me just increase the font size back up so you can see a better view here. Okay, so I'm going to open up SIeve, and I'm going to import my diffraction pattern here. So this is the Chinese white paint pigment. And I'm going to import this into the database. And now you'll see it's coming up with many different versions of calcite. So it's very clear that calcite is the first phase that it found. And what I can do here is just to show you the crystallite size module. I'm going to change my profile function to crystallite size. And then I'm going to change this crystallite diameter slider here. And let me zoom in this peak region here. And then as I increase the crystallite size, I'm actually going to narrow these rings down, or these peaks here. So I can essentially do a quick crystallite size estimation. Okay, so now I have my first calcite selected. What I'm going to do is I'm going to accept this phase. And now the database has searched for a second phase. So it's come up with anatase, or titanium oxide. So again, this is a very obvious phase. It's hit this major peak here at 25 degrees 2 theta. And let me zoom in this peak. And again, I'm going to set the profile function to a crystallite size. And then I'm going to narrow down this peak profile here. Now you see that there is a little offset going on. Maybe a little 2 theta correction offset needs to be applied. But because of our search windows, we allow some wiggle room. So even if there is an offset, well, you can easily correct for that. A lot of times you're still going to be able to get the correct phase. And another nice thing you'll notice is that, let me just zoom in these middle peaks here. We can now see the new gradient fill that's being applied. So it really kind of highlights the area under some of these peak profiles here. Just allows them to be viewed a little more easily. All right, so I'm going to accept my anatase. And now it's come up with a bunch of different phases for the third phase. And if I just look at this first one, Frankieite, if I look at that, it's not really matching my peaks that well. So actually none of these phases are really giving me a high GOM or a high goodness of match. But one thing you can notice is if you look at this low angle peak here at 11.6 degrees 2 theta. So this is an unmatched peak. And if I look at all the other unmatched peaks, it's actually a fairly high intensity compared to the remaining peaks that were not matched. So what this is telling me is that this is actually a strong peak in a minor phase. And that's one of the reasons why the search match is not picking this up as a top match, is because of the low intensity. So let me show you how to use the new single peak search to essentially target this peak and get the correct phase. So I'm going to take this peak, I'm going to right click this with my mouse, and then in the pop-up menu, I'm going to select single peak search. And it's telling me the peak I've selected, so it's giving me in D spacings. Now I'm going to click the zoom in peak button so we can get a better view of the actual peak that we're looking at. The default search window here is 0.01 angstroms, but you can narrow this. So if you wanted to look at 0.001, you can look at a really narrow point of this peak, or you can expand the view. So let's say we want to do 0.05, or you could even do 0.1. So you can set the range or the peak window that you want to search. But generally, I find that 0.01 seems to work for many cases. So I'm going to select 0.01. I'm going to click the Run Search button. And now what has happened is that since I've targeted this peak and I've designated this as a strong line peak in my minor phase, now the search match has come up with gypsum. And we know that gypsum is the third phase in my paint pigment. And it's been able to rule out all those other false positives that had come up previously in my search results. So it's a really nice way to target those minor peaks for your minor and trace phase analysis. Okay, so that's an example of some of the 1D diffraction features that we've implemented. But we also have the ability to import 2D diffraction patterns. Now, 2D diffraction patterns, as you can see on this left-hand screenshot, are actually consist of an image. And in many cases, it'll actually consist of multiple images. And if you're not familiar with 2D diffraction patterns and using an area detector, you may ask, well, why do you need multiple images to do a 2D diffraction pattern analysis? And that's because the detector is actually using multiple 2 theta angle captures because it can't capture the entire 2 theta range in one shot. So you'll see that there's actually 5 images here. So if you see these five thumbnail images, each one is showing a different 2 theta angle position of the detector. Now, there is going to be some 2 theta overlap when you import these types of patterns, and we do account for that. So some of the new features that you'll see for the 2D diffraction patterns is that 2D images are now dynamically displayed when importing multiple files. So in many cases, as I mentioned, when you're importing these multiple files, and sometimes these are referred to as frame files, so you would have multiple frames of data. When you're importing, now you'll see each frame, and you'll see the image of that frame being dynamically displayed in the upper left-hand corner, and then a thumbnail of that image is going to be produced and then shown in this list of thumbnails. You'll also see that there's now a red vertical line, which indicates the progress of the pattern integration. All right, so I'm going to show you how to analyze the 2D diffraction patterns. But first, I just want to explain, again, if you're not familiar with 2D diffraction patterns, how you essentially analyze those in the PDF database. So the first thing you would do is you import your 2D diffraction pattern. Now, here is the key difference. We integrate the 2D pattern down to a 1D pattern. So once you do that, once you go and integrate the entire image, you're essentially downsampling from a 2D image down to a 1D XY plot. And once you have that 1D pattern, well, you can use all of your traditional techniques that you would use for peak finding. So you can remove the background, you can smooth the data, you can strip the K alpha 2, and then you can extract the peak positions or the fingerprint of the material. And once you do that, you can employ all the traditional search algorithms to identify the phases of the material using a reference database such as the powder diffraction file. So really the key difference when you're analyzing 2D patterns is integrating from the 2D pattern down to the 1D pattern. And I'm going to show you how this is done. Okay, so in this next database demonstration, I'm going to import 5 2D diffraction patterns into SIeve Plus for phase ID, and I'm going to import an ibuprofen pattern. So I'm going to go back to the database here, and I'm going to make sure that all data is selected at the top. Because I'd mentioned in the new PDF5 Plus database, you now have access to all the organic patterns that were previously in PDF4 Organics, and this also includes many different pharmaceutical materials such as ibuprofen. So I'm going to now click the Import 2D Diffraction Pattern button. I'm going to select 5 different frame files. So these are all 5 different 2D diffraction patterns. It's of the same material, but taken using multiple 2D 2 theta angle captures. And I'm going to select all 5 at the same time and click the Open button. And now what's happening, let me expand this window. On the left-hand side, you see the 2D image, but now you see this new vertical line that is showing you the pattern or the process of integration. And it's now putting a thumbnail view of that 2D image on the top right-hand side. So you can easily view all the different thumbnails of the different 2D images that were imported. Now, each thumbnail or each frame of data corresponds to a 1D plot on this traditional 1D plot on the bottom right-hand side. And they're color coordinated. So this first one has a red line underneath the thumbnail, and that corresponds to this red plot here. Now, what's nice about these new thumbnails is you can actually refine the integration manually if you want to. So let's say I click this second thumbnail here. Now I've brought up the second 2D image that I'd imported. I can click on this button that says Integrate Sector. And then using the mouse, I can actually select the sector of data that I want to have integrated. And because this has a blue line under this thumbnail, I know that that corresponds to this blue 1D pattern here on the plot at the bottom. And if I just look at this sector from essentially we're at 5 degrees to 23 degrees, it's just going to integrate it down from 5 degrees to 23 degrees on this 1D plot here. Now, as I expand this sector, it's actually going to increase the range, and you'll see the integration is now increasing here. If I click back to integrate entire pattern, well, that's going to integrate over the entire image. And that's going to give me this full pattern here. I found that in the majority of cases, if you integrate over the entire pattern, that seems to be pretty good, certainly good enough for phase ID. So you don't always have to go in and manually integrate the sector that you want, but the option is certainly there. So now that we've integrated these 5 different patterns, I'm going to then process this data so we can get a list of peak positions. So what has happened now is that we've stitched and merged all those 5 integrated patterns into a single 1D plot that you see here. So now we're kind of working with a more traditional 1D pattern. And the beauty of that is now we can employ all of our traditional techniques and algorithms that we've had for 1D patterns. We can now employ them to this pattern that was integrated from the 2D patterns. And we can remove the background, as you can see here. You can smooth the data if you want to. You can strip the K alpha too. In this case, we're going to skip that. And then you can get your peak search and get your peak positions. So now I'm going to import this into SIeve Plus for phase ID. Now I'm going to change the subfile. Previously, it was set to mineral related because I was working with my paint pigment. So now I'm going to select pharmaceutical as my subfile because I'm working with ibuprofen, which is a pharmaceutical material. And even if I didn't know it was ibuprofen, if I knew I was working with a pharmaceutical material, I would just want to select that here in the subfile list. So I have pharmaceutical selected. I'm going to click the apply filter button. And now it has come up with ibuprofen as my match. Now you'll notice that in the compound name, we actually don't have ibuprofen. So in some cases, you may want to look at the alternate name because the alternate name will also have the pharmaceutical or drug name in it. So we have ibuprofen here as the top, essentially top 4 matches, actually top 5 matches are ibuprofen. So if we look at the top match of ibuprofen, we can look at the bottom 2D images. And if you look at the top cross-section, so if you look at the white image or the white rings, that is the top cross-section of the 2D images that I imported. So that's actually the raw data. So let me zoom in a little bit so you can get a better view of these 2D images. So again, the top cross-section, that's the raw data. Now the bottom image, so the bottom rings, that's actually simulated 2D patterns from the database pattern of ibuprofen. And the next thing I'm going to do is I'm going to change the intensity scale from linear to square root. Many times you'll find with these 2D images, because the way low intensity rings are displayed, sometimes they're hard to see. Unlike a 1D pattern, where low intensity doesn't really change in terms of how easy it is to see, it's just going to be a lower value on your y-axis. With 2D images, lower intensity rings are actually darker. They're not as bright as a high intensity ring. So in those cases, you do want to bump up the intensity scale to something like a square root or even a logarithmic. So I just changed the intensity scale to square root. And now we've bumped up the intensities of our rings. And I'm just going to zoom in even further, just so you can see how well our patterns are matching. So I'm looking at this first image here of ibuprofen, and you can see that we're matching all the peaks, and the peak positions are matching very nicely. So we can be very confident that this 2D analysis, we're matching ibuprofen. And when you have your analysis here, you can dynamically change the crystal light size. So right now I have it set to 500 angstroms, but you can lower the crystal light size. So if you want to broaden the rings, I can lower it here. It's at around 200 angstroms. And now it's making the rings much more broad. But you can see now that the rings are becoming more broad than the rings in the raw data. So the raw data actually has a much higher crystal light size. So that's how you import a 2D pattern into the database for analysis. And if you want to go back to the 1D view, you can click the 1D patterns tab on the left here. And now we're kind of looking in the more traditional 1D view. And as with the 2D view, I can also change the crystal light size, and I can dynamically change the crystal light diameter to better match my data. So very easier to switch between the 1D view and the 2D view. So those are some of the new features that we've added in terms of the 2D diffraction patterns and analyzing those in the database. I will mention that we did implement PDF software auto updates in last year's release. We had a fall update for the PDF4 Plus, and that was deployed in November of last year, and that included some new features and bug fixes. And due to the popularity of that, we are also going to deploy a fall update for the upcoming PDF5 Plus 2024 database as well.